Okay, this video is to help us review the order of operations. So first I'm going to review what the order of operations is, and then I'll work through a few examples using integers and fractions to help us see what this looks like. So lots of you probably learned the order of operations with an acronym like PEMDAS, or Please Excuse My Dear Aunt Sally. So let me write that out. So PEMDAS, or Please Excuse My Dear Aunt Sally, is just a way to remember the order that you should perform operations like multiplication, division, and exponents. So the first thing that you should do whenever you approach a math expression that you want to simplify is to simplify anything that's inside parentheses. The next thing you're going to want to do is look at the exponents and simplify the exponents. Then you're going to do multiplication and division. Now, some people get these confused because they want to do all the multiplication and then do all the division. But what you actually want to do is work from left to right and do all the multiplication and division in the order that it appears from left to right. Then you're going to do the same thing with addition and subtraction. So you'll do all the addition and subtraction that you see working from left to right. So I'm going to put this in a little box so that we don't lose it. That's kind of your important takeaway from this video. And now let's look at a few examples. I'll put the first example over here. So we're going to do 2 divided by 6 minus 4 squared plus 5. Okay, so first thing I want to do with order of operations is do all the parentheses. So I'm going to simplify that 6 minus 4. So 6 minus 4 is 2. So now I've got 2 divided by 2 squared plus 5. The next thing I want to do is simplify my exponents. So 2 squared is 4, so 2 divided by 4 plus 5. Next thing I'm going to do is the division. So I would do any multiplication and division from left to right. The first division I see is this 2 divided by 4, which is 1/2 plus 5. And then we just perform that addition. So 1/2 plus 5 is going to be 5.5. Or you could write it as 5.5, or you could write it as 11 halves. Any of those are acceptable answers, and I'm not going to be super picky about them. I will let you know if I want a specific form of answer. Okay, that is one example. Let's take a look at another example. Maybe I'll switch to blue just to be exciting this time. We're going to look at one that involves some more fraction operations because that can be a little bit tricky for us. So put number 2, so I'm going to look at the second example. So let's do 1/2 minus 1/3 divided by 3 1/4 minus 1 5/6. Okay, first of all, I hate this color blue, so I'm going to change it back to black, so I'm sorry if that's annoying. The first thing that I want to do is evaluate everything in the parentheses. So I'm going to handle this first one and simplify that, and then handle this one separately and simplify that. So let's look at the first one, 1/2 minus 1/3. We know when we're adding or subtracting fractions, the first thing we have to do is find a common denominator. So the common denominator I'm going to choose for this first set of parentheses is going to be 6. So I know that 2 and 3 both go into 6, so I'm going to rewrite both these fractions so they have a denominator of 6. If you look at the first fraction of 1/2, I multiply the denominator by 3 to get to the 6. So I'm going to multiply the numerator by 3 as well to get 3/6. Similar process is going to give me 2/6 for the equivalent fraction of 1/3. And then I can just perform this subtraction. So 3/6 minus 2/6 means that I have 3 pieces of size 1/6. I'm going to take away 2 of those pieces, and I'm just going to be left with 1/6. Okay, I've kind of been ignoring the second set of parentheses, so let's come back to it. The second set of parentheses is going to require a little bit extra work because before we can find a common denominator, we need to write these fractions instead of as mixed numbers as improper fractions. So I'm going to go ahead and do first. So 3 1/4 can be rewritten as 13/4. And one simple way to do this to figure out the improper fraction is take the big number, multiply it by the denominator to get 12, and then you add whatever's on the top. So let me erase those lines, if I can do that. Oh good, I can. So I get the 13/4. Similarly, I'm going to get 11/6 for that one. Now I need to find a common denominator for 4ths and 6ths. So there are several different ways to find our common denominator. One, you can just multiply the two denominators together. So I could have 4 times 6 is 24. So I could rewrite both these fractions with a denominator of 24. In this case, there is actually a smaller denominator you can use, and that is 12. The reason I know 12 will work is because I know that 4 and 6 both go into 12. So I can take this 4ths and multiply both the numerator and the denominator by 3 to get to 12ths. I'll get 39/12. And I can do the same thing over here with my 6ths. I multiply the top and the bottom by 4, and by 2, and I get 22/12. Okay. Now I have two fractions that are being subtracted that have the same denominator, so I can just subtract them. So 39 minus 22 is going to be 17. Yeah, 17/12. Okay, so I've simplified all the parentheses, and that required me to do some subtraction. Now I just have this one division problem left. And if you remember about dividing fractions, what we do is we keep the first one, and then we're going to multiply by the reciprocal, which means that we're going to take this second fraction and we're going to flip it on top of itself and change this into a multiplication problem. Now this is nice because multiplying fractions is super easy. You just multiply straight across. So you do 1 times 12 and 6 times 17. Before I do that, I'm just going to do a little bit of simplifying. I can simplify this 6 and this 12 because they both have a common factor of 6. So I can say I have 1 6 on the top, and I have 2 times 6 on the top, which equals 12. Cancel those out. So then I am left with, let me go back to the black. I'm left with 2/17. And that is equivalent to this nice, lovely thing that we started with.